All right, today we're going to tackle something super powerful. It's a way of thinking that helps you make the absolute best, most optimal decision when you're working with limits. It has a fancy name, linear programming. But trust me, by the end of this, you'll see how it can bring this amazing clarity to choices that feel, well, pretty complex.
So, here's the plan. We'll start with a dilemma that I think we've all been in. Then, we'll introduce this tool, linear programming, as the solution. After that, we'll get our hands dirty and use it to solve a real-world problem, step by step. We're not just going to find the answer, we'll also see how to make the results even better. And finally, we'll talk about how you can use this exact same thinking for your own big decisions.
You know that feeling, right? You've got this big goal you want to hit, but you only have so much time, or a tight budget, or just a certain amount of materials to work with. So, with all those limits staring you down, how in the world do you pick the single best path forward? That's the big question we're going to answer today.
And that right there, that's what we can call the optimizer's dilemma. It's this constant balancing act. On one side, you have your goal, something you want to maximize, like your profit. On the other side, you've got the very real limits that you just have to work within. Think about it. Maybe you want to squeeze every last drop of fun out of an evening, but you're limited to just a couple of hours. Or a company wants to absolutely maximize its profit, but it's constrained by the raw materials it has in the warehouse. This tension, this fundamental push and pull between your goal and your limits, is exactly the kind of problem linear programming was born to solve.
Okay, let's dive into it. Linear programming, at its heart, is really just made up of three key building blocks. And once you get these three ideas, you can pretty much describe and solve any optimization problem you can think of.
First, you've got what's called the objective function. Now, this sounds technical, but it's really not. It's just a super clear way of answering the question, what is the one thing I'm trying to achieve here? Are you trying to make the most money possible? Or maybe spend the absolute least? This formula just captures that one single goal.
Okay, next up, decision variables. These are the knobs you can turn, the choices you actually get to make. How many of product X should we build? How many of product Y? These are the quantities we have control over, the things we need to figure out to reach our goal.
And last but not least, we have the constraints. These are the rules of the game, the hard limits you can't get around. You only have so many hours of machine time. You absolutely have to produce a certain number of units to meet an existing order. These rules basically draw the boundaries of the sandbox you get to play in.
Okay, enough theory, right? Let's get our hands dirty and make this real. We're going to use this exact framework to help a business, the AOSOE Furniture Company, figure out its perfect production plan.
So here's the puzzle for AOSOYE Furniture. Their goal, their objective function, is super clear. Make as much profit as possible. The choices they can make, their decision variables, are how many executive chairs to produce and how many ordinary chairs to produce. And they are dealing with a few constraints. They only have 100 hours a week on machine I, 120 on machine 2, and they have a standing order they have to fill for at least 15 ordinary chairs.
Now, what's really cool here is that because we're only dealing with two choices, the two kinds of chairs, we can actually see the answer. We're going to use something called the graphical method. It sounds complex, but don't worry. It's basically a 6-step process that turns this whole business problem into a simple map, a treasure map really, that will lead us right to the best answer.
Okay, first step, let's draw our boundaries. We'll start with machine I. You can literally think of this line on the graph as a big old fence. Any mix of chairs on one side of this fence is possible. Any mix on the other side? Nope, impossible. It would just take too much time on that first machine. All right, now let's add the other fences. Here's the line for machine 2's time limit and another one for that standing order of 15 ordinary chairs. And watch what happens. Every time we add a new rule, the space we have to play in, it just keeps shrinking. And what we're left with is this. This shaded area is what's known as the feasible region. I like to call it the zone of possibilities. Any single point inside this shape is a valid production plan that follows all the rules. But we don't want just any plan. We want the best plan. And here is the absolute magic of this whole thing. The very best answer, the jackpot, is always going to be hiding at one of the corners of this shape. So we have our map. We know where the treasure is buried, at the corners. Now it's time to go digging and find that sweet spot. The math behind linear programming guarantees that our maximum profit isn't hiding somewhere in the middle of that zone. It's going to be sitting right at one of those intersections. And from here, it's actually pretty straightforward. All we have to do is figure out the address, or the coordinates, for each corner point of our zone. Then we just plug the number of executive and ordinary chairs from each one of those corners into our profit formula, our original objective function, and see which one spits out the biggest number.
And when we run the numbers for all 4 corners, bam! One of them clearly stands out. Point B gives us a total profit of 71,875 cents. And this isn't just a good profit, it is the absolute, mathematically proven, maximum profit that AOSOE can make given their current resources.
So, what does that actually mean for the folks on the factory floor? It translates into a simple, concrete plan of action. To hit that maximum possible profit, the company needs to produce about 12 executive chairs and 43 ordinary chairs every single week. No guesswork. We've found the single best answer.
But wait, there's more. Linear programming isn't just about finding one single static answer. It can also help us ask really powerful strategic questions. For example, what's the real dollar value of getting just one more hour of a resource that's holding you back?
And that's where this amazing idea called shadow costs or shadow prices comes into play. It helps us answer a really critical business question. If we could get our hands on one more hour of labor, or one more hour on a machine, how much extra profit would that one single hour actually create for us?
Let's look at a similar problem to see how this works. Let's say a company's maximum profit was $49,000, and their biggest constraint, the thing holding them back, was labor hours. Now, what if they could get just one more hour of labor? If they reran the numbers, their new maximum profit would climb to $49,466.67.
That difference, that N466.67, is the shadow cost. So what does that number mean? It means that one extra hour of labor is literally worth an extra N466.67 in profit. It's not a guess, it's a hard number. This tells a manager exactly how much they should be willing to pay for that extra hour, maybe for overtime. It turns a gut feel decision into a data-driven one.
So, let's zoom out for a second. We went from this problem we all face, having big goals with limited resources, all the way to a super specific production plan for a furniture company. We even figured out the exact value of their time. The example might have been about chairs, but this way of thinking is a universal toolkit you can use for almost anything.
And that really is the biggest takeaway. The language of linear programming forces you to be incredibly clear. What is your actual goal, your objective function? What are the choices you can truly make, your decision variables? And what are the real-world rules, your constraints? So think about it. If you apply this way of thinking to your career, your budget, heck, even just your weekly schedule, you can start to find your perfect path. So I'll leave you with this. What's the most important thing you need to optimize?